Verify ready for launch. FTS.
FTS go.
Props go. ABI.
ABI's go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
You are looking at a live view of SpaceX's Falcon 9 rocket as we prepare to launch the MTG-S1 third-generation Sounder 1 mission from Launch Complex 39A at Kennedy Space Center in Florida in just under 14 minutes from now. My name is Shreya Chintalapudi, and I'm a supply chain reliability engineer here at SpaceX.
And I'm Zachary Lupin, an avionics supply chain engineer, and we are joining you live from SpaceX in Hawthorne, California. Today we will be delivering EUMETSAT's MTG-S1 mission to geosynchronous transfer orbit.
EUMETSAT operates a system of meteorological satellites that observe the atmosphere, ocean, and land surfaces 24 hours a day, 365 days a year. MTG-S1 will be Europe's first operational sounding satellite in geostationary orbit.
Now, MTG-S1 is carrying two missions this evening, the infrared sounder and the Copernicus Sentinel-4 ultraviolet visible near-infrared light imaging spectrometer. And in combination with Meteosat-12, which is already in orbit, MTG-S1 will enable weather and climate scientists to get a 4D vision of the dynamics and composition of the atmosphere.
At just about T-minus 13 minutes, everything is looking good for an on-time liftoff of 5:04 p.m. Eastern Time, and the range is ready to support. Weather is currently green for launch with no concerns here at the top of the window. If for any reason we are unable to launch today, a backup opportunity is available tomorrow at the same time. That's 5:04 p.m. Eastern Time. And with that, let's take a look to learn a little bit more about the Falcon 9 supporting today's mission.
There you can see Falcon 9 on your screen, a two-stage rocket that is 229 feet tall and getting ready for liftoff in just over 12 minutes from now. Now at launch, Falcon 9 produces about 1.75 million pounds of thrust. The bottom section is the first stage, or booster, and is powered by 9 Merlin engines. The 9 Merlin M1D engines burn for the first couple of minutes of flight, carrying Falcon 9 through the thickest layers of Earth's atmosphere.
Early in flight, Falcon 9 performs a gravity turn, a smooth pitch maneuver that adds a slight rate to the first stage to start moving it sideways. Getting to orbit is a bit like throwing a ball so fast it never lands. Once the first stage completes its portion of the mission, it shuts down and separates. Falcon 9 sheds the booster to shed mass, enable recovery of the booster. Stage 2 and the payload keep climbing faster and more efficiently without the extra weight, accelerating to around 17,500 miles per hour or 28,000 kilometers per hour.
That's definitely very fast. Now, after stage separation, today's booster will land on our drone ship. Just read the instructions, which you can see there on your screen, currently stationed in the Atlantic Ocean. And this particular booster will be returning to Earth for its 9th time today. Now, the second stage takes over from there, powered by a single Merlin vacuum engine.
Spacecraft is on internal power.
Good call out there. The second stage is powered by a single Merlin vacuum engine, also known as the MVAC. And with its extended nozzle and optimized design, the MVAC provides maximum performance in the vacuum of space. And tonight, we'll ignite that engine twice before deploying the MTG-S1 payload into orbit.
Topping off the rocket stack is the payload fairing, a 17-foot wide carbon composite shell that protects the satellite during the uphill trip through the atmosphere. There's a photo of the payload being encapsulated in the fairing a few days ago. About 3 minutes into flight, both halves of the fairing will separate and parachute back to Earth. Both fairing halves on today's mission are flying for their first time today. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again on future launches.
Now, so much of what makes Falcon 9 remarkable happens in flight. We have stages separating, the first stage landing itself on a drone ship in the middle of the ocean, fairings parachuting back to Earth, all ready for another flight to space. Every part of Falcon 9 is part of a larger design that comes together to do one thing, and that's to escape gravity. And that is the first step in building our multiplanetary future.
And that's a future I'm definitely excited to be a part of. While the countdown continues, here is a video from our customer for today's mission, EUMETSAT.
Day in, day out, we provide our data. It gets used by weather services and it's used to help people stay safe. All the data that goes into the weather forecast models so that they can then project it forward in time. A lot of what we do in supporting weather forecasting supports action. So the value from our data comes when somebody far down the line does something or makes a decision and takes an action.
And today we're launching MTG-S1. The first European sounding satellite in geostationary orbit. This satellite will complement data from MTG-S1 12 launched in 2022 and will cause a revolution in weather forecasting and climate monitoring. At a time when climate change is having such an impact on severe weather events, this data will ensure that European societies are even more resilient to those changes.
MTG-S1 is the fruit of the collaboration and the strong, long-lasting collaboration between ESA and EUMETSAT. MTG-S1 spacecraft will host two missions. One is the infrared sounder, and then the Copernicus Sentinel-4 mission. The infrared sounder and Sentinel-4 mission are separate but complementary missions.
The Sentinel-4 will add new capabilities to Copernicus. The data will be used by the Copernicus Atmosphere Monitoring Service to supplement air quality, pollution and climate monitoring.
The infrared sounder can identify regions of instability in the atmosphere before clouds have even started to form. This will allow scientists and engineers to derive a four-dimensional picture of water vapor and temperature in the atmosphere.
In combination with data from METOSAT 12, the synergies will bring impactful benefits to users. It will enable weather and climate scientists to get full division of the dynamics and composition of the atmosphere.
Both these instruments are, frankly, masterpieces of technology, developed in Europe by European industry and European agencies.
What excites us is the new information we will get with this data. It's not only the data itself, but it will provide more information that we have now, and that's really exciting. And we are looking forward to try to use that data in scientific and in an operational context and help the forecasters to use those data and those information to get better forecasts.
MTG is the combination of more than a decade of partnership. It takes from a project on paper to a spacecraft that will be launched today over a decade and involves thousands of people and consortium of more than 120 companies which are led by OHB.
I would really like to thank all the teams involved in developing this truly outstanding satellite system. We are really looking forward to seeing this system operational in space, and that starts today with the launch.
At T-minus 6 minutes and 45 seconds, Falcon 9 is tracking no issues and our payload is healthy. Now, Falcon 9 has been loading propellant since the T-minus 35 minute mark, and it'll finish loading up to around the T-minus 2 minute mark.
Quick reminder there, if for some reason we do not launch today, we do have a backup opportunity tomorrow at 5:04 p.m. Eastern Time.
Now, coming up next in the countdown, the transporter
Stage
erector.
1 RP1 load complete.
Good call out there for Stage 1 RP loading completion. Next up in the countdown, the transporter erector, or TE, will begin to retract away from Falcon 9. That's the large truss structure you see standing next to the rocket. It's hinged at the base and connected to the launch mount beneath the first stage. First, we'll see the clamp arms open around the Falcon 9 second stage. Then the TE will begin to pivot back, slowly swinging away from the vehicle. And it'll reach full recline at about the T-minus 3 minute and 40 second mark.
Still got a little time there. You might also hear that transporter erector, a TE, be called the strong back. It's the same structure, just a different name. The TE rolls Falcon 9 out to the pad, raises it vertical, and stays connected through the final seconds to launch. It provides fuel, power, telemetry, and command connections between ground systems and Falcon 9.
Just about 40 seconds away from starting to see those clamp arms opening around the second stage on our vehicle stack.
Tanks are pressing for Stromberg retract.
And another good call out there.
Those clamps that you see at the top of the TE help stabilize the second stage ahead of launch. As they open,
the retract has started.
There's that call out there. As they open, the rocket is fully free at the top. Now, both stages are nearly fully loaded with about 1 million pounds of propellant, which includes RP1, a highly refined kerosene, and liquid oxygen, which we will also refer to as LOX.
And there you can see those clamp arms beginning to open around the second stage there on your screen. Now, propellant is loaded late in the countdown, and that's intentional. Colder propellants are denser, and denser propellants mean more performance out of the same tanks. The colder it is, the more mass that you can move. And before any of that propellant flows, the plumbing and engines get chilled down, and that prevents thermal shock and boil off when the ultra-cold liquid starts moving. And you may hear that referred to as engine chill.
Loading wraps in 2 steps. The first stage finishes around T-minus 3 minutes, so we still have got around 30 seconds there, and then the second stage will finish about a minute later. You've probably noticed these white clouds venting from the rocket. It's actually condensation. As the liquid oxygen warms slightly inside the tanks, some of it kind of boils off, and then that gas is vented to manage the pressure. When the vented oxygen hits the warm air outside, it instantly condenses into clouds. It's the same principle as your breath on a cold morning, just a much bigger scale.
Load complete.
Good call out there.
Now at the T-minus 60 second mark, Falcon 9 will enter startup, and at that point, the rocket's onboard flight computers will have taken over. And from then on, the countdown will be fully autonomous.
Once we hit inside of T-minus 2 minutes, the 9 Merlin 1D engines will ignite. Once they're at full power, Falcon 9 will lift off of the pad and begin its climb to orbit. As of now, the payload remains healthy. Falcon 9 is tracking no issues. Weather is still green, and the range is ready to support our T0 of 5:04 p.m. Eastern Time. With that, we're proceeding into the last few minutes here of terminal count.
Coming up shortly, we should hear that.
Stage 2 LOX load complete.
And there's that call out for Stage 2 LOX loading completion. Falcon 9 is now fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Now, next major milestone coming up in about 40 seconds from now will be that call out for Falcon 9 being in startup.
Gas launch closeouts.
We should be hearing that call out for Falcon 9 startup in just a few moments from now.
Falcon 9 is in startup.
And great call out there. Lastly, we'll hear the final go, no-go from our launch director.
Launch director, go for launch.
And great call out there. LD is go for launch. So let's sit back and watch as Falcon 9 takes our MTG-S1 mission to space.
T minus 30 seconds. T minus 15. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go MTG-S1.
Vehicles pitching downrange.
Heavy propulsion is coming.
We've just passed 30 seconds and counting. Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center in Florida. In just a few
Falcon
seconds...
9 power and telemetry are nominal.
Amazing call out there. Everything is nominal. Great to hear. In just a few seconds, we'll throttle the engines down.
Falcon 9 is supersonic.
Great call out again. We'll throttle the engines down in preparation for max Q, a period of maximum aerodynamic pressure.
Now we should be hearing that call out for max Q in just a few moments from now.
Max Q.
Amazing. So we just heard that call out for max Q. The rocket has just passed. It'll experience the greatest mechanical stress in flight at that point. The rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. You can keep an eye on the Stage 1 telemetry on the bottom of your screen.
Now we're going to have several...
Back in flight chill.
Good call out there. We're going to have several events coming up in quick succession, and we should hear all of those called out by Mission Control, starting with main engine cutoff, or MECO, then stage separation, SES1, and lastly fairing separation. MECO is where we shut down all 9 M1D engines on the first stage. Stage separation is when the first and second stages of Falcon separate from one another.
And second engine start, 1 or SES1, is when we will light the MVAC engine on the second stage for the first time. Less than a minute later, the fairing will then jettison from the second stage as it's no longer needed to protect the payload once we're in space. So keep an eye out for these events happening back to back. It's all coming up in about 10-15 seconds from now. Just waiting on
MECO.
that. There's that MECO call out they were looking for.
Stage separation confirmed.
MVAC ignition.
And there you heard, maybe even saw those events that happened back to back, which again were MECO, followed by stage separation, and then SES1. And in just about 20 seconds from now, we'll have fairing separation.
Fairing separation confirmed.
Amazing view there of fairing separation. Now, as we mentioned earlier, we will be attempting to retrieve these fairing halves once they fall back to Earth, and they'll be taken to shore by our ocean recovery vessel, Doug.
We're approaching just about 4 minutes into today's mission. At about T plus 6 minutes, you should see on your screen first stage's entry burn. To start the entry burn, we're going to relight 3 M1D engines, starting with the center engine, known as E9, followed shortly after by E1 and E5, which is similar to pumping the brakes to slow down the vehicle as it passes back into Earth's atmosphere. We need to slow down to reduce re-entry forces, which then helps us recover and reuse the first stage. During that entry burn, Falcon 9 is decelerating by firing its Merlin engines, but we still are moving very fast. This causes the vehicle to fly through Merlin's exhaust gases.
Both vehicles are following a nominal trajectory.
Great call out there, still moving nominal. This causes the vehicle to fly through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle's surface. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, that soot builds up a little more on the outside of the vehicle. Oftentimes, prior to launch, you can see that soot from prior flights on the first stage.
Now, just as a reminder, the second stage of our Falcon rocket is on the right-hand side of your screen, currently taking our payload to orbit, and on the left-hand side of your screen is our Falcon 9 booster, which is going to be making its way back down to Earth. This booster is flying for its 9th time today, having previously supported NASA Crew 9, RRT-1, Firefly Blue Ghost Mission 1, FROM-2, Sirius XM-10, and 3 Starlink missions. You can keep an eye on the telemetry of both stages at the bottom left-hand corner of your screen for the booster and the right-hand side for the second stage. Coming up in just about 20 seconds from now, we should be hearing the call-out for the entry burn of the Falcon 9 first stage, which, as a reminder, is on the left-hand side of your screen.
Stage 1, entry burn startup.
Stage 1 FTS is saved.
And good call out there for entry burn startup of the Falcon 9 first stage.
Stage 1, entry burn shutdown.
And great call out there for entry burn shutdown of our Falcon 9 first stage.
Great to hear. One of the most iconic things about Falcon 9 is its reusability. It's key to lowering the cost of spaceflight, which enables more investments in critical scientific research. The Falcon 9 first stage that is supporting today's mission is performing this entry burn for the 9th time.
Now, the Merlins on the first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during ascent and descent. At liftoff, Falcon 9's first stage has thrust greater than 5 747 airplanes at full power. And the MVAC engine on the second stage, which has a much wider nozzle, is optimized to 220,500 pounds of thrust in vacuum.
In a little over 30 seconds, the second stage Merlin vacuum engine will shut down.
Stage 1, entry transonic.
There's that call out there. And after that, we will start our landing burn on the first stage.
Stage 2 is in terminal guidance. Stage 2 FTS is saved.
Stage 1, landing burn.
And good call out there for the landing burn start on our Falcon 9 first stage.
Nominal orbit insertion.
Stage 1, landing leg deploy. Stage 1, landing confirmed.
And there's that call out of landing confirmation for our Falcon 9 first stage. As a reminder, this was the 9th launch and landing for this first stage, which previously launched NASA Crew 9, RRT-1, Firefly Blue Ghost Mission 1, FROM-2, Sirius XM-10, and 3 Starlink missions. We also heard a call out for nominal orbital insertion.
With that, Stage 2 is embarking on its coast phase, after which the MVAC engine will relight for a second time at about T plus 26 minutes. This will be followed by another short coast and then payload deploy.
We're going to take a quick break now and leave you with some space jams, and we'll see you back here in about 15 minutes.
Welcome back to our live coverage of the MTG-S1 mission. We've had a great mission so far with an on-time liftoff of 5:04 p.m. Eastern Time from Launch Complex 39A at Kennedy Space Center in Florida. After a successful stage separation, the first stage returned to Earth with a precision landing on our drone ship. Just read the instructions. And just before the break, we had confirmation of nominal orbital insertion.
And coming up next, the Merlin vacuum engine on the second stage will reignite for the second time, and you might hear it referred to as SES-2. So we're currently listening in for that call out about 20 seconds from now. Now this burn will last a little more than a minute before the second stage engine shuts down for the second time, and that'll be called out as SECO-2. And then we'll have another coast phase, which will last just a few minutes.
MVAC ignition.
And good call out there for MVAC ignition. So as I mentioned, this burn will last a little more than a minute before the second stage engine shuts down. Now our customer for tonight's mission is EUMETSAT. The METEOSAT third generation sounder, or MTG-S1, will be the first ever European sounding satellite in geostationary orbit. MTG-S1 is the second satellite of the MTG system, and the imaging satellite METEOSAT 12 is already in orbit.
MTG-S1 actually carries two missions, the infrared sounder and the Copernicus Sentinel-4 ultraviolet visible near-infrared light imaging spectrometer. The Copernicus Sentinel-4 mission is an ultraviolet, visible, and near-infrared sounder. It's expected to send hourly data over Europe on aerosols, which are fine particles in the atmosphere, as well as on the concentrations of nitrogen dioxide, or NO2.
MVAC shutdown.
MVAC shutdown, great call out there. As I was saying, nitrogen dioxide, or NO2.
Nominal orbit insertion.
Nominal orbit insertion, there's that call out there. We've got ozone, or O3, and sulfur dioxide, which is SO2. With two different types of satellites, both disseminating data in near real time, MTG is expected to revolutionize numerical weather prediction and nowcasting of high impact weather in Europe and in Africa. And with that second shutdown of the MVAC engine, the second stage is going to coast for about 6 minutes. We're going to take a short break for that coast, and we'll be back for the deployment of the MTG-S1 satellite. See you guys in a few.
Welcome back to our continued coverage of the MTG-S1 mission. Now, before the break, the Merlin vacuum engine on the second stage reignited and burned for a little more than a minute before successfully shutting down for the second time.
Now we're a little less than a minute away from expected payload deploy, and we should be able to see that as it happens. A little bit before the break, I was speaking about our customers, so want to reiterate some of the fantastic things that they're doing here for tonight's mission with EUMETSAT. That is the third Meteosat, the Meteosat third generation sounder, or MTG-S1. It'll be the first European sounding satellite in geostationary orbit. MTG-S1 is the second satellite of the MTG system. The imaging satellite Meteosat 12 is already in orbit. MTG-S1 carries two missions, the infrared sounder and the Copernicus Sentinel-4 ultraviolet visible near-infrared light imaging spectrometer. In combination with data from Meteosat 12, MTG-S1 will enable weather and climate scientists to get a 4D vision of the dynamics and composition of the atmosphere.
Now, in combination with data from Meteosat 12, MTG-S1 will enable weather and climate scientists to get that 4D vision, and with two different types of satellites, both disseminating data in near real time, MTG is expected to revolutionize numerical weather prediction and nowcasting of high-impact weather in both Europe and Africa. Now we should be hearing that call out for payload deployment in just about 12 seconds from now.
MTG-S1 payload deploy confirmed.
Super exciting call out to hear there. You can see the successful deployment of the MTG-S1 geostationary weather satellite.
And with successful payload deployment, that'll wrap up tonight's live coverage of the MTG-S1 mission. All of us here at SpaceX want to thank our customer, EUMETSAT. We also want to thank the Eastern Range and Federal Aviation Administration for supporting today's mission. Now, if you're interested in more launch coverage, be sure to check spacex.com/launches for the most up-to-date information. And, of course, remember to follow @SpaceX on X. Thanks for tuning in, and we'll see you again soon.